So, for an example, if we have this circle is going to represent the domain, and this circle is going to represent the range, so the y numbers. And I'm going to put some numbers in here and show how they go together. So let's say we had like -3, 0, and 5. And on this side, 1, 2, and 8. And if we had a mapping, it might look something like this. If we were looking for ordered pairs, I'm sorry, 0, 8, 2. These are like points on a graph, like in a Cartesian coordinate plane, an x and a y axis. This would be a function. Every single number in that first circle is only matched up to one number in the second circle. This is a function. Is it always red? It can be boxes. You could see them written as English. All right, so this is a function. Domain. So -3 only compared to one number over here. Okay. And if you also look at this one, it's not only is this one a function, but it's a special function. Every single y value, y number, is only paired up to one x value. So not only is it a function, but this is also a one-to-one function. Here's the way I think about it. I think about these are girls and these are boys on the second one, and these are couples. So -3 and 1 are going together. Okay? They're in a monotonous relationship. They're only the other person. Same thing with 0. 0 and 8. If 0's the girl and 8's the boy, they're only seeing one other person. They're in a monotonous relationship. It's a one-to-one function. One-to-one. Okay. Let's look at another mapping. If we were to look at this mapping, go ahead and write it down. So again, if you sort of think about, does every person, every girl over here have only one boyfriend? Yes, from the girl's perspective, a boyfriend. 5. Boyfriend. So it is a function. This is a function because every x in the domain is only paired to one y value. However, is it a one-to-one function? Does every boy only have one girlfriend? Right. 5 there has 2 girlfriends. So this is a function, but it is not one-to-one. It's not monotonous. One-to-one? No, I'm trying to make a metaphor. Is that All right, and then the last one, let's do one more mapping. Might look something like this. And ask you, is it a function? Does every number in the first column only match to one number in the second? No. So this is not a function. Any questions about the differences that are up there, those three scenarios? Yeah. It's not a function because the 2 is paired up to a 6 and it's paired up to the 2 in the second one. So there's 2 arrows coming off. Not one. It would be a one-to-one function. Oh, all right. All right, we could see a representation like a graph and be asked, is it a function or not? So let's look at those. Let's look at some, oh, well, there's some. So let's look at this one first. Sorry. They could list it out instead of having the circles like somebody asked, is it always in a circle? So is this a function? Is every x only paired with one y? So what you're looking for is, does the x number or any x numbers repeating? So it's a function. If I were to ask you what the domain and the range is, the domain are all the first numbers, all the x's. Okay, so this is the domain. You would just list it. -4, -1, 0, 2, and 3. And the range would be the second numbers. So 3, -2, -4, 3. So they might ask you that a little bit of a different way, but it's still the same concept. And you guys did say it was a function? Why is it a function? Max. Right. None of the x's repeat. Every x is paired up exactly with one y. Okay. For anybody, does this look familiar? Have you done this before? I'm just curious. Sometimes, okay. All right, so this is coming back to you then. All right, let's look at some graphs. They might ask you, is this graph a function? Here's one way that we can tell by using the vertical line test. Okay, so if you want to just kind of sketch the graph, the points don't really matter here. Just sketch what the shape is. And I'll give you a minute to do that. Just sketch the shapes. You drop an up and down line through the graph. It's only allowed to touch it one time. Okay? So if I were to look at this parabola, all right, if I were to drop a line through there, I'm just going to use the dotted line. How many times would that dotted line hit the graph? Just one time. If I draw it over here, it only hits it one time. In fact, no matter where I drop it, it will only hit it one time. So this is a function. Okay. Look at the line. Again, if we drop a vertical line, anywhere on there, It only is going to hit it one time, no matter where I put it. So it's a function. How about this V graph? Yeah? And no matter where I put that line, right, it's only going to hit it one time. That should be vertical. It's only going to hit it one time. So, yeah, this one's a function. Why is that writing so weird? Okay. How about the last one? It's not a function. Because if we were to drop it here, it hits it in 2 places, and that's not allowed. And what that says here is that, let's see, 1, 2, 3, 4, 5. So like at 7, it has the coordinates 7, that looks maybe 4, and 7, what is it, -4 maybe? And you can see now from what we did previously, see how the x-coordinate repeats. That's what we're checking for. So this is not a function. Not a function. If it's a function, there's a possibility it could be a one-to-one, and we can test the graph for that. Let me show you how that one works. It's called a horizontal line test. So this checks for function. And then a horizontal line test, we'll check to see if it's a one-to-one function. It can't be one-to-one unless it's a function to begin with. So if we were to take one and go through here, is this function one-to-one? Does it hit it one time? The blue line? Hits it twice. So it's a function, but it's not one-to-one. How about here? If I draw a horizontal anywhere, is it a one-to-one? Yep, it only hits it one place. What about this V graph? Is it one-to-one? No. Horizontally, it hits it twice. Okay, so it's a function, but it's not one-to-one. And if it's not a function, it cannot be one-to-one. Questions about the graphs? And you want to go to the y equals screen? Move this over somehow. There we go. If you clear it all out, go to the y equals screen, and if we wanted to type in 2x plus 1, you might need help typing in, everybody find the x button kind of in the top upper half of the calculator, so it's like x and theta. Type in 2x plus 1. If you hit graph, you'll be able to see what the line's supposed to look like. Right here in the upper right corner, that's what we graphed by hand. Okay. Now, if you need to see what the ordered pairs are, like what that table would have looked like, you could go to second, and I think it's, where is it? Yeah, thank you. Here's all kinds of points you can choose to plot on your paper. So your calculator could do some of the work for you. All right? Everybody find that? This should say x squared. Okay? Let me rewrite it real fast. F of x equals x squared plus 3. All this means is that you're going to substitute -4 in for every x that you see. This does not mean f times -4. It means f